Okay, in this lesson we'll take a look at the attention systems of the brain. We've seen that attention and working memory are related systems. What we're paying attention to is what enters into our working memory system. And the working memory system is a limited system, but so too is our attention system. Now let's first ask why it is that we have attention systems in the brain. And the idea is that there's just too much information impinging upon our senses for the brain to be processing simultaneously. So the concept here is that brains are limited processors. They have a lot of computational power, but not infinite computational power, right? So if there is too much information in the world to be processed by your central processor, you have to have a mechanism of selecting out just certain streams of information for further processing. And that's what attention systems do in the brain. So the attention systems are an evolved adaptation because due to the limitations of computing power in brains. Now, researchers understand attention as serving three main functions. The attention systems, first, they select from all the information impinging on our senses. The attention systems are going to select some channels of sensory information over others. So a selection function is going to limit the brain's computations to certain stimuli over others. Secondly, attention systems give priority and, in fact, enhance the processing of whatever it is that was selected. So if we imagine this scene out here, we got some people in the grass and a ball and a garbage can or something, and we are watching this scene, we might be paying attention to the ball, right? Not the trash can. We might be paying attention to the ball, and so our attention system has selected the ball over other things in the environment. And another consequence of the attention system is that the processing of the ball is enhanced at the expense, right, of processing other things in the environment. So two of the functions here, selection and enhancement, then it gets to this idea that if there's too much information in the world to be processing deeply at the same time, then we have to select certain channels of stimuli for further processing, and the further processing is the enhancement shown over here. And then finally, the attention systems can be vigilant. They can help us sustain the enhanced processing on the item of interest. So attention systems have evolved to perform three main functions: to select items for further processing. That further processing, we understand that as an enhancement of the processing of one item at the expense of other items that were not selected, and then also to maintain the enhanced processing of the item of interest. So let's go into a little bit more detail about the attention systems. Here we have our brain, and we have our working memory box up here, and there are these two indicated areas of the brain, one in parietal lobe, one in frontal lobe here. Two of several attention areas of the brain, and they are shown connected through axons and so on, connected to the visual part of the brain here, visual cortex. And so the person here is watching this scene here. We got a tree, got a house, got a bird, and let's say somebody says, pay attention to the tree, right? So the idea is that these brain areas here, we'll call this the top-down attention system, are going to respond to the directive here, and those brain areas are going to bias in a positive way the processing of the tree at the expense of the other two stimuli in the environment, the house and the bird. Right, so as we focus on the tree, our eyes are open, we're paying attention to the tree, our eyes are focused on the tree. We still are registering the presence of the bird in the house, right? So visual cortical areas are processing those items, but the attention system is giving preferential resources to the processing of the tree. And we want to think of this as actual physical signals, action potentials, racing down axons to those cells that are processing the tree, so that processing is happening more efficiently and in an enhanced way at the expense of the processing of the house and the bird. So we can think of the top-down attention system, the one that we kind of willfully direct, in this case in response to a request, as a pointing system, a kind of an internal brain pointing system. That given all the information that's hitting our senses and being processed by our perceptual systems, the attention system can favor the processing of certain streams of information over others, like a pointer. And of course, what it is that we're paying attention to then has preferential access to the working memory system. So we will be conscious of the tree because we're paying attention to the tree. Of course, that doesn't mean that we'll never shift our attention. Our attention can shift, but right now we're focusing on the tree. Now, one way to measure the effects of attention is to do simple experiments like shown down here. So imagine we have an empty screen here, and the subject is fixating in the center of the screen. Now, at some point in time, some other object will appear on the screen, and then they just simply have to push a button to respond when they detect the object. Now, if they're not told where the object is going to show up on the screen, it takes a certain amount of time to respond to the object. But if they're given this instruction, press the key when you see the target at the left of the screen. So in other words, now the subject is expecting, right, the target to appear on the left of the screen. Well, that simple instruction here speeds up the detection and response time to the stimulus. So it's as if attention, right, can improve the speed and accuracy of stimulus detection and discrimination. So that's a kind of an experimental demonstration of the impact of these signals coming from the attention system to our perceptual systems. That processing is facilitated when the attentional pointer is directed at some kind of a stimulus in the environment. Okay, let's take a look at one more aspect of attention. We're going to call this covert attention. So here we have our brain, we have our attention systems here, and remember the attention systems act like sort of internal pointers, giving privileged processing to some items in our perception at the expense of others. And here we have our working memory system, right? Now here's our eyes, and let's say we're at the park and we're watching a dog as it approaches us in the park. But simultaneously then a friend of ours comes up, right? And so we might shift our eye gaze towards our friend because our friend starts to talk to us. And so we're going to be listening to what they are saying. So that's a gaze shift. And now normally to somebody watching my eyes shifting here, they would say, well, I'm paying attention to the person and what they're saying, right? So the eyes usually are an indication of what somebody's paying attention to. But in this case, because the dog was potentially threatening to me, see, what my attention system is going to do is maintain attention on the dog, right, even though I shifted my eye gaze towards the person. And this would be called covert attention, because overtly it looks like I'm paying attention to the person. My eye gaze is towards the person. But covertly, my attention systems are processing the dog, so they're enhancing the processing of the dog. Now, as a consequence, because my attention systems are favoring the dog, the processing of the person, my friend, and what they're saying is not as well processed as if it were the subject of attention, right? And so we have the phenomenon where we can be looking right at somebody and appear to be listening to them, but we're really paying attention to the dog. So in our working memory, we have, yes, we're looking at our friend, but the dog is commanding our attentional resources, and so we're not well processing what our friend is saying. But of course, if that dog makes a move, even though we were looking at our friend, if the dog makes some kind of threatening move because of the attentional processing, the biasing of that stream of information, we're going to have a quick response to the dog. So this is called covert attention, as opposed to overt shift in eye gaze. Covertly, we remain, our attention systems give a preferential processing to the dog.